Welcome everyone. Today my team member Asma and I, Ashley, will be presenting research paper number 10 titled Why Does Your Data Leak? Uncovering Data Leakage in Cloud from Mobile Apps. This research explores why mobile apps using cloud services are prone to data leakage, especially when using cloud backend services, and how these vulnerabilities can be identified and prevented using an automated tool. Overview of cloud and mobile app usage. Mobile apps increasingly rely on cloud backends for services like data storage, notifications, and analytics. However, we have seen a rise in data leaks from these cloud services, including personal information and corporate data. This research aims to uncover the reasons behind such leaks and develop tools to systematically detect vulnerabilities in mobile apps using cloud APIs. Developers had to create and maintain the entire infrastructure from scratch, and with the rapid rise of mobile apps, cloud services have become their preferred choice for developing. To make this process easier, cloud technology introduced something called Mobile Backend as a Service, or MBAAS. This service provides ready-made tools for APIs, allowing developers to create apps more quickly without worrying about managing all the backend infrastructures themselves. This means they can focus on making the app better for the users. They offer scalability, availability, and quick deployment, making them ideal for handling large volumes of data. But with this increased use, we have seen massive data leaks. How to use Cloud API. Data leakage often stems from access control problems, which dictate who can access certain data. There are two key components: authentication, which verifies a user identity, and authorization, which controls what that user is allowed to access. In mobile apps, there are two main types of users: normal users, who provide credentials like app keys, and developers, who use root keys to access and manage the cloud services. It was found that data leaks occur due to misuse of authentication keys, particularly in Azure and AWS, and misconfiguration in authorization permissions, which were common in Firebase and AWS. Key findings. Improper use of cloud APIs has led to significant data leaks. For example, one breach exposed 280 million users, records that include highly sensitive information like usernames, passwords, emails, and even GPS locations. Verizon has also experienced a major breach, leaking 100 megabytes of corporate secrets via an unsecured AWS S3 bucket. This shows that even large companies are exposed to these types of attacks. This exists across a wide range of mobile apps affecting millions of users. This happens because mobile apps increasingly use cloud services like AWS, Firebase, and Azure as their backend, known as Mobile Backend as a Service. Root causes of data leaks. There are two main root causes of data leaks: misuse of authentication keys, which identifies the users, and misconfiguration of authorization permissions, which determines what resources the user can access. First, key misuse, where developers mistakenly embedded root access keys into the apps, given full access. This issue continues to occur in both AWS and Azure services. Second, misconfigure permission, where developers don't set up access rules properly, leaving databases wide open to unauthorized access. Lack of authorization or misconfiguration can make the authorization layer ineffective, resulting in data leaks. To solve these roots, a tool is needed that includes a verification method to prevent data leakage. Now, I would like to pass it over to my team member Asma, who will discuss the leak scope tool.
Hello, my name is Asma. I will introduce a tool developed to address these vulnerabilities called leak scope. This tool identifies potential data leaks by analyzing how code APIs are used in mobile apps. Leak scope is capable of detection misconfigurations, improper use of authentication keys, and it supports major cloud providers like AWS, Azure, and Firebase. Leakscope has three main components: Cloud API identification, string value analysis, and vulnerability identification. In Cloud API identification, which takes APKs that the package files used by Android apps and examines them to identify which Cloud APIs the app is using. It uses a hashing function to generate a unique signature for each API. In a string value analysis, here it extracts any authentication keys used by the app. These keys are important because they control access to sensitive information. In a vulnerability identification, Leakscope then uses the keys it found to look for potential security risks. It checks if these keys could be misused to get unauthorized access to data. By combining these steps, LeakScope helps ensure that apps are secure and don't accidentally expose any sensitive information. This slide explains the vulnerability detection process and how LeakScope works to find security issues. In step number 1, it's identify cloud APIs and keys used by the app. LeakScope first checks which cloud services and keys the app is using. These keys control access to cloud resources, so it's important to know which ones are there. In step number 2, analyze key usage in mobile apps. Leakscope then looks at how these keys are being used within the app to see if they are handled safely. In step number 3, verify application permissions without accessing private data. Finally, Leakscope checks if the app's permissions are set correctly to prevent unauthorized access, making sure private data stays protected. These steps help Leakscope detect possible security vulnerabilities without actually accessing any private information. In the Leakscope evaluation, over 2 weeks, Leakscope collected data from 1.9 million app names and analyzed the full content of many free apps. As a result, LeakScope found over 15,000 mobile apps with a total of over 17,000 security problems, putting their cloud servers at risk of data leaks. Vulnerabilities were found in apps using cloud services like AWS, Azure, and Firebase. Some examples of misused keys. In AWS, developers embed in root access keys which allow full access to cloud resources. In Azure, developers using full access keys instead of more restricted keys in mobile apps. Firebase, also some apps had misconfigured databases where sensitive information is stored without proper access control. These practices expose apps to potential attacks, and these results highlight how common these issues are and why apps need better security to protect user data. In a conclusion, Lexscope showed that many mobile apps have serious security problems when using cloud APIs. It found major weaknesses in how mobile apps interact with cloud services, which can lead to data leaks. There are plans to make Leakscope even better by allowing it to handle keys that are generated during the app use. Also, working together with cloud providers like AWS and Azure could help reduce these risks. Finally, Leakscope is a great start in finding and fixing vulnerabilities, but it also shows that more needs to be done to protect users' data. With how many apps depend on cloud services, better security and partnerships with cloud providers could make a big difference in keeping our information safe. Thank you all for your time and attention. That concludes everything we wanted to share with you about why does your data leak. If you have any questions or would like to discuss any part of the presentation, please feel free to leave your comments and questions in the project discussion. We would be happy to answer. Thanks again.